Hi everybody, this is Chapter 1, Section 2, Measuring Matter. This time I thought I'd go over the vocabulary with you. Weight is the measurement of the force of gravity on an object. Mass is a measurement of how much matter is in an object. The International System of Units, or we can call them SI units, is the system of units used by scientists all around the world to measure the properties of matter. Volume is the amount of space that matter occupies, and density is the measurement of how much mass of a substance there is in a given volume. Let's look at the difference between weight and mass. So weight measures the amount of force of gravity on an object. So if you're on Earth, your weight would be different than if you travel, let's say, to the moon, where gravity is less. And then mass is how much matter that object contains, and it is not affected by the force of gravity. So it does not change, let's say, if I travel to the moon. Okay? So the moon's gravitational pull is about 1/6 that of Earth. So if I were to travel to the moon, I would weigh about 1/6 of my weight, but my mass would remain the same. For the units of mass, we use the International System of Units, which is the metric system. Our basic units are grams, liters, and meters. All around the world, scientists use the International System of Units, or the metric system, for taking their measurements, even the ones here in the United States. So when we take measurements in class, whether it be measurements of distance or of mass, we are going to make sure that we use the metric system too. Now in class, we have found the volume of an irregularly shaped object. In this case, we have a key. We have found the volume of minerals, right? You put the mineral in a graduated cylinder to see how much water it displaced, and that was the mineral's volume. We can also find the volume of a regularly shaped object. We can simply calculate the length times the width times the height, which gives us the volume. And we use that measurement to find the object's density. And remember, density is how much mass an object has per unit of volume. And we can calculate that by dividing the mass times the volume. Whether we find the volume of a regular shaped object or an irregular shaped object, we still calculate the density the same way, mass divided by volume. So let's practice calculating density of a regularly shaped object. Here we have a rectangle, 6 centimeters by 3 centimeters by 5 centimeters with a mass of 270 grams. How are we going to calculate its density? Remember, if we want to find the volume of a regularly shaped object, let's say a cereal box, we need to find the length times the width times the height. That will give us the volume. In this case, 6 centimeters times 3 centimeters times 5 centimeters equals 90 centimeters cubed. Remember that density equals mass divided by volume, so let's plug in the information that we know. Here we have density equals 270 grams, which is our mass, divided by 90 centimeters cubed, which is our volume, which equals 3 grams per centimeter cubed. Remember, grams per centimeter cubed is our label for density. We will be practicing some more density problems in class, both with regularly shaped and irregularly shaped objects. See you soon.